Question 6. So we need to make a decision about these statements just here. Now there's a number of ways you can approach the first one. So we want to be able to say, is it going to always be positive? So how do we demonstrate that? Well, you could complete the square. You could even differentiate. You know you've got a quadratic. You know it's a happy quadratic. So it's going to look like this just here. But the idea is where is it? Is it there? Or maybe is it up here? So as we know it's a happy quadratic, we could just go and try and find the roots of it. So does it have any roots? So is b squared minus 4ac, if it's less than 0, then that must be the case. So let's find out. So b squared, so I've got minus 6 squared, take away 4 times 1 times 10. So that's going to give me 36, take away 40, minus 4 is less than 0. So no roots. Like I said, you could complete the square to find out this vertex point just here, which would be relatively straightforward to do. You could differentiate to find out the turning point, of course, whichever you prefer. And I suppose if you're differentiating, then obviously you can say it's a minimum point as well. Right, so the second part, looking at this part, I didn't tick this, did we? So it's always true. Right, so this one just down here. Well, if A is positive, I agree that to be the case, because if you just divide both sides by A, yeah, that makes sense, doesn't it? But what about if A is negative? Okay, what about if I've got a negative in front of it? It doesn't work then, right? It's not the case, right? Because you know if you're going to divide through by a negative, you then got to swap the sign around. So it's not going to make sense. You would what I always do is I take this bit over to the right and then the b over here. So in fact you would get so I've added ax to both sides and I've taken away b from both sides, and then divide by the a. So that's what we would have there. All right, so that's if I've got a negative in front of the a, right? So therefore it's going to mess it up. So it's sometimes true. And then the last part, it says the difference between consecutive square numbers is odd. So I've got one square number, okay, something squared. So then the next square number will be n plus 1 squared. So obviously that's the larger one. And if I take away the smaller one, so the difference between the two. Right, let's see what happens. So n squared plus 2n plus 1, that's n plus 1 squared. Take away n squared, and that's 2n plus 1. There we go, odd. So that is always true.